I'm going to speak today about AI agents that serve a common good. As Carolina was saying, it's a relatively new team, so we've been around for 6 months or so, and we this is more or less the initial presentations that we are doing, and expect some more blog posts and some more publicity from the team to inform the community of what we're doing. In the last months, weeks. Yeah, so let's get started. Here a brief agenda on my talk today. So I'm gonna give a lightning fast introduction to AI agents, what they are and what composes them. Thank you. Then I'm gonna move over to also another introduction to prediction markets. So thanks for Ben for the previous presentation there on interesting use cases for prediction markets on information systems. This example is probably a little bit easier than what he suggested, but also relevant. Finally, I have 4 use cases that we think are relevant, especially for this use case of making, aiding human users in Web3. So the first one is, of course, prediction markets, simply because it's something, it's our biggest focus right now on the team. The second one is then simplifying access to Web3, which is still quite complex for non-crypto users. The third one is DeFi, and the fourth is governance. Yeah, and maybe real quick, if you guys have any questions, also feel free to interrupt me or raise your hand, or in the end, I'm also happy to take questions, as you prefer. Okay, so going to AI agents. Not sure if you guys had a chance to participate in the 50 events on Web3 and AI this EthCC, but if you haven't, a very quick introduction here. I'm doing a kind of comparison between the old and the new way of having agents. The old way, or what people used to do, was mostly having an agent that was initialized quite randomly, so with kind of random weights, and it was able to perform a set of actions. So it could, if it was, for example, an RPG game, it could jump, move, shoot, or do something else. This action then led to changes in the environment, and these changes in the environment implied in a change of state, which I think, yeah, anyways, a change in state. And this change of state also led to a reward to the agent. So the agent was able to get a positive reward if this action was something that the system or the training wanted to incentivize, or a negative reward if it wanted to be penalized. And going through many loops, the agent was able to learn from these actions and from this training, and was able to perform a given action then very well. For example, play AlphaGo, or do something similar. There were many applications for that. This was the case until a few years ago. Now, with the advent of LLMs, is of course a little bit different. The agent is able to perform out of the box a lot of different things. So ChatGPT, Mistral, Gemini, they're all very powerful and able to do different tasks without these training loops that I said before. So the new agent way of doing things is simply using the LLM with a given more tools, which I'm gonna introduce later, and performing different actions. What I also wanted to highlight, I think it's important in this slide, is that for the old way of the reinforcement learning way was still very mathematical heavy, so data scientist heavy. We're using going low level for the training, for the rewards, and defining the actions. Now, with the LLM based approach, they are a lot more software heavy. So all those kind of training and all those actions, they were abstracted away for the developer. So it's a lot easier to get started. Yeah, and just going a little bit more detail of composes the new agent, we have 4 main building blocks. The first one is the LLM itself, is what gives the capabilities, or what the engine, so to say, of the agent. It gives its planning and reasoning capabilities, and in the end, it's a bunch of API calls to providers. They can either be closed source providers like OpenAI, Gemini, or many others, or they can be an open source provider like Ollama or some other open source models which you can download locally, execute in your machine. And this is the kind of thing that you invoke, and the agent asks the LLM for, let's say, directions, or you simply invoke and ask for the next step, and it's able to coordinate the movements of the agent, so to say. So this move, jump, gun, it comes from this LLM, for example. The second part is this memory. So The LLMs, of course, have a limitation on the amount of tokens or words that they can receive. If you want to overcome these limitations, because as you have, for example, a given task, this task needs to involve multiple interactions. So move once, now jump, now do something else. This, of course, you need to store this memory somewhere. And to store this memory somewhere, there are vector databases now, so you're able to store your information somewhere else. And as you're calling the agent, you are able to tell the agent basically, hey, there is somewhere else, so the vector database, where you can look for additional information, look for additional context, go look there and find the items that closely resemble what you are invoking, what you're asking about. This is a kind of external brain, so to say. The third thing are the tools themselves. So instead of, let's say, in the ChatGPT, normally you just have access to data it saw until a given cutoff in years. So now if you want, let's say, to give it additional capabilities, so superpowers, you can give, for example, the ability to scrape the web or to search Google or to do something else. So this is what we call tools. And finally, there is the control logic, which manages the progress towards a given goal. In a single agent case, it's just a glorified while loop. But if you have multi-agents, then of course you have somewhat more elaborate things on that, right? So when you have multiple agents collaborating, for example, one agent might talk to the other, and then you need to answer for the response from the other agent, and they hold they have a conversation. So this all belongs to the control logic that for these new agents. Cool. That's what about AI agents. So I will continue to the next section then. Now it's a lightning fast introduction to prediction markets, just for setting the stage for the use cases. So prediction markets, I tried depicting. I'm not sure if you guys can read that, but depicting the mechanism of prediction markets here. In very general terms, the idea of prediction markets is simply where someone can ask a question there. So let's say, will it rain in Brussels tomorrow? Then you fund this market, so you place a bounty, so 10 euros or something like that. Then in this market, people can place bets on it. So you can say, oh, I think it's gonna rain. I buy or I place a bet for yes, or I don't think so. I place a bet for no. Then it rained, or let's assume it rained. Then in the afterwards, the people who betted yes, then they get their money back plus a reward. And who placed the bet in no, then they simply lost their money here, their bet. And this is this is generalized, a simple example of a prediction market. If you come more from a TradFi background, they are similar to futures, where you also have a fixed contract where you can buy or sell a security for a given price in the future. But this is more related to future events. As I said, weather data, or we're also interested in, of course, cryptocurrency events, but it's pretty much general. So especially the kinds of markets we're also seeing are binary ones, so yes and no. But this also applies to scalar markets where you have continuous range of the outcomes. But yeah, focusing on binary markets right now. Coming back to my example, just to make sure I communicate all the necessary terms here. Okay, you can see also my mouse, great. So we have four main actors here. Oops, I'm sorry. The funder is the one that creates a market and places bounty, deposits liquidity into the market. Or the one who asks the question. Then there are the buyers and sellers who place bets, and in more technical terms, those actors, they interact within ERC 1155 contract, and they are able to buy or sell outcome tokens. So in those outcome tokens, they are within that contract, and they represent the possible outcomes. So yes and no for those binary markets. Then the third one is the resolver. So the resolver is the one who tells, okay, it really rained in Brussels today. So he's responsible for kind of defining the outcome and defining who lost and who won the bets, basically. And then there is a fourth actor, which is the arbitrator. Normally for the markets we interact with, this is called it's Claros, is another protocol, and they are responsible for settling disputes. So let's say if there is a malicious actor resolving those markets, then people who participate in those markets, they can ask for an arbitrage, and the arbitrators then go there and have a mechanism for solving those conflicts. This is roughly how it works with, those are the actors that are involved in prediction markets. I also wanted to mention that there are multiple bonding curves possible. So once the funder creates a market here, it also dictates how the pricing works for each token. So you, in this case, or normally the prediction markets we work with, they are called CPMM. So they have, fixed product market makers. It's basically an AMM, right? So the X times Y equals K, just Uniswap V2 mechanism. This is how the bonding curves work, but for this specific example, but there are multiple bonding curves possible. Yes, that's what I had to say about prediction markets. Then some references for reading afterwards if interested. And yes, now coming to the concrete use cases if you guys have no questions. Okay. Okay, this is a lot of content in this slide. Let's unpack this for a moment. The first case here is, so I introduced the AI agents, what they are, and what are prediction markets as well, and what is the use case for that. So first of all, how can the agents interact with those markets? Basically, completing any action that is possible via smart contracts. In this case, so providing liquidity, they can also buy and sell outcome tokens. And of course, if they are successful, they can make a profit. But the bigger question is, why should we have AI agents participating in those markets, right? Why is it interesting for human users that AI agents participate that? LLMs are really good on reproducing breadth and depth of human knowledge and also aggregating unstructured data. What that means is they have a very large capability of fetching data from different sources, aggregating them, and making a decision. And if they are able to kind of aggregate data from various sources, that leads us to believe that they're also able to make reliable predictions, or they're going to be right a larger percentage of time than the time they are going to be wrong. So that translates to good accuracy. And if we assume that they're going to have a good accuracy, that means that we can build kind of swarm of agents, and this swarm of agents are going to deliver reliable predictions or predictions to a future event which can be predicted to a given probability. So if you ask, will it rain in Berlin tomorrow, then it will hopefully give a reliable prediction, or as good as it can be if our agents are good enough. And what this leads is of having a kind of truth-telling machine. So we are able to ask, if the agents are that good, you're able to go to this platform and ask any question you want and get a reliable probability out of it. So weather data is of course one of the things, but you can think of many use cases where those agents are able to predict reliable probabilities, and that's really powerful. This is a great use case that we would be able to achieve if we continue working on our agents and making them even more reliable. This agent is just for you guys to know how a prediction market looks like on Gnosis. So this is from Omen, and this screen is just for buying or selling tokens, where you have a collateral and you exchange your collateral. In this case, is XDAI for yes and no tokens. Those are the outcome tokens. Great. So truth-telling machine is use case number one. Now a more, let's say, easier use case for the simplified access to Web3. So needless to mention that wallets are still a very hard problem for non-crypto users. So there are a bunch of teams working on that. For example, Matri is doing a very nice job of making the wallet easier to interact for users. But problems are still there, right? So managing seed phrases, recovery is also not trivial, and so on and so forth. Is still a big friction point for non-crypto users, for getting more people into crypto. And most importantly, scams, hacks, and problems and exploits still happen a lot. So everybody knows that. And one interesting use case that we find and we see more and more people trying to do is kind of an AI companion, Web3 companion, which then acts and avoids that you authorize scamming tokens, that you avoid interacting with fake protocols, and that's partially implemented already in MetaMask, where a lot of people also use crypto users, but we think this can also be more and more extended. I'm sorry, for the benefit of the users, for the security of the users. This is the first use case. The second use case that I'm personally interested in is this option of ditch the wallet completely and go headless. And what I mean by that is using crypto directly in your chat, for example, where you have, it can be, in this example is actually WhatsApp, but it can also be Telegram or whatever or other application that you have. It gives you a more natural experience, and of course it can also, because of the crypto composability, it allows you to be very, very open and easy to expand, simply because you can integrate with other protocols in a permissionless way. And just as some suggestions for features here, of course, Safe Wallet provides a lot of security guarantees as recovery mechanisms, max spending, and so on. And you can also, again, because of this permissionless nature of crypto, you can have community contribution a very easy way. So anyone can add new functionality to it, which also gives rise to security challenges, but from a technical standpoint, it's very composable. And just for explaining what this image is about, is just actually an application from Brazil. So I'm sorry for the Portuguese. I'm not sure everybody can understand this, but it's a way they suggest having a bank. It's called Maggie, I guess. It allows you to have a full bank inside your WhatsApp, which has very high penetration in Brazil. More than 90% of the smartphones have WhatsApp already. So that gives an automatic bank account for everyone inside WhatsApp where they already are. So this is kind of powerful. And that's something I think having AI agents that interpret your chat messages, your audio messages, and your intents in general can be very powerful. That's the first use case that I have. Actually, the second. And the third one is, of course, DeFi. Is still also relatively complex to explore. Tons of protocol, things that the normal user has trouble understanding. Also very hard to navigate. There are multiple chains, multiple protocols doing the same or claiming they do the same, or anyways, all very, very, very complex. And the idea here would be to use AI agents to reduce the complexity of the protocols, and especially about the interactions with those protocols. The first example here would be reducing the complexity in this, the example in the bottom right. This is a Giza agent that rebalances your deposits on Uniswap v3. And that's kind of a simple use case, but still for, let's say, individual liquidity providers, it's still hard for you to rebalance your position every day. You need to track those balances, maybe across multiple chains, across multiple protocols. So that's something that, of course, an agent can help you with, and that gives you a lighter experience, a lighter interaction, hands-on interaction, so to say. And the second thing would be earning money with improved investment strategies. And that's something that OLAS, which is an ecosystem partner of Gnosis, an interesting project, is also building. So they also build agents for those DeFi use cases in order for improved risk-adjusted investment strategies, which is what they call baby degen. Also a nice use case for DeFi. And then for the last use case that I also interesting is the governance case, which is for DAO governance initially. As we all know, also DAO participation is still a major problem. There are numerous proposals, very hard to navigate, that leads to participation being very small. So in order to solve this, especially this major number of proposals, one of the ideas, again, from our friends from OLAS, they suggest this agent to which you can delegate. So you can delegate your voting tokens, and by delegating to this agent, the agent finally votes in your behalf, which can be complicated. Of course, some security measures are important, but by voting in your behalf, you can control which kind of actions you expect from this agent. Do you expect it to prefer, let's say, actions in some kind of let's say orientation. Do you prefer the protocol to save as much money as possible? Do you prefer to invest in new projects? Do you prefer it to be conservative or aggressive? So you can kind of tune this agent to participate for you and automate your DAO participation, thus making your experience a lot easier, a lot lighter. That's the one thing for participating in DAOs. The second thing would be the DAO role management. So is this example here? It's from HATS protocol. They have this kind of a hierarchy of participation on the DAO. So they can also be managing the different roles and allocating treasury resources, for example. So agents can also wear one or more hats of this of the DAO, so of the DAO management, thus also helping with the management and administrative tasks of the DAO. And finally comes one interesting use case that I actually stole from Ilya from Near Protocol. So he suggests having an AI president, and the AI president would then serve citizens or and allocate the resources in an optimal way in order for kind of allocating all the treasury or the money from the taxes in an optimal way, depending on the way that you coordinate this agent. So should they invest more in education, have a budget for this, budget for that? This is also, technically speaking, extremely interesting, but of course we're still a long way to go because there are, of course, democracy issues and some other concerns that would involve having an AI or an agent with so much power. So of course, they're a long way ahead of it, but technically speaking, extremely interesting to think about this option. This was my last use case. So yeah, this is the QR code, how you guys can find more about our work. We're present in the major social media channels as well, and that's where we're gonna post the other blog posts and on our information. Thank you so much for your time. Yeah.
If anyone have any questions, we have some time. So.
I just had a question about the prediction market. So what's kind of the state for the user experience at the moment in terms of like allowing like a user to just delegate funds and then have the AI agent just make bets and try and generate yield? Because I'm assuming that's kind of the direction that they're trying to go in.
Yeah, the main direction here, or the KPI that we are tracking, is actually the accuracy of those agents. So we are trying to make the swarm of agents that are able to answer any question with a reasonable accuracy. So that's really the stage that we find ourselves in. Regarding user experience, of course, anybody can go to those markets and place a bet. But regarding the composability or letting agents kind of provide liquidity to the agent itself, it's still not there. So it's still not possible for, let's say, this agent has a very good accuracy, let me delegate funds to it in order for it to participate in markets for me on my behalf. That's still not there. But that's also an interesting use case we want to explore. Yes. Did I answer your question?
Yeah, not there from a technical point of view or from like just a strategy point of view? Like delegating money to the agent to your behalf.
You mean so yes, delegating agents delegate funds to your agents to place bets on your behalf. Yeah, it's a technically interesting use case that we wanted to explore. Yes, but it's still not there. So we don't have any functionality for that at the moment. Yeah.
Hey. What are some of the biggest risks you see around the intersection of AI and crypto?
Very important point. Biggest risks is I think regulation is probably an important one, because if, for example, if you develop an agent that runs on chain and you can it can do some let's say detrimental activities on chain, it's very hard to stop it as well, right? Because it's you cannot really stop blockchain from executing now if they have like Gnosis validators distributed around the entire world. So it's of course very tricky, and so that's why you also need to be very aware of the capabilities of those agents, because they can become very hard to stop. So and also to respect the kind of instructions that we're placing to it. So yeah, tread with care.
Okay, then I think it's a wrap up. Thank you so much, Gabriel.